Hello, everybody, and welcome to We Measure the World, a podcast produced by scientists for scientists.
Unbeknownst to us, when we lifted up one of our colleagues was out there lifting up this tube, and the water ran out from the back into the rice that was standing there, and it sounded for all the world like a water moccasin just shooting through. And my colleague almost jumped into my arms. And we then realized it was just water out the back of the tube, but we were shaking for a good 5 minutes after that.
That's a small taste of what we have in store for you today. We Measure the World explores interesting environmental research trends, how scientists are solving research issues, and what tools are helping them better understand measurements across the entire soil-plant-atmosphere continuum. Stay current on applied environmental research, measuring methods, and more. Thanks for spending time with us. All right, let's get started. Today, we're going to meet the people behind We Measure the World, a group of scientists who are passionate about measuring the environment. Their day job is to design new environmental sensors and improve existing ones for other scientists. Sensors they've developed are routinely used to gather data all along the soil-plant-atmosphere continuum. They even have a sensor sitting on Mars. More about that in an upcoming podcast. Today, we'll interview Drs. Doug Kobos and Colin Campbell, also Leo Rivera, Chris Chambers, Holly Lane, and world-renowned soil physicist and company founder, Dr. Galen Campbell. So for this first part, we've got Drs. Doug Kobos, Colin Campbell, and Galen Campbell. And we're going to start with Doug, who's a research scientist and the director of the Environment Division at Meter. He also holds an adjunct appointment in the Department of Crop and Soil Sciences at Washington State University, where he co-teaches environmental biophysics. Doug's master's degree from Texas A&M and PhD from the University of Minnesota focused on field-scale fluxes of CO2 and mercury vapor. All right, Doug, so tell us about the most interesting project you worked on before you came to Meter.
I suppose the most interesting project that I worked on was probably the mercury vapor flux project. So until that point, there had not been a lot of direct measurement of surface to atmosphere mercury vapor transport, which that whole problem is pretty interesting because the diffuse sources of mercury vapor are known to contribute a lot to the mercury loading in the aquatic systems, that then it gets converted to methylmercury, which is bioaccumulates and it's super toxic. And so trying to figure out where that mercury is coming from, other than, point sources like coal-fired power plants, is a pretty interesting problem. And so developing that relaxed eddy accumulation system was quite challenging because the mercury vapor analyzers are very slow response. And so having to work through the problems to be able to use a micrometeorological technique to accurately measure mercury vapor was pretty fun.
So what made you decide to come to work at Meter, and why do you like doing what you do?
Well, so the decision to come to Meter was pretty well a no-brainer. I had just finished up a PhD at Minnesota working on the Mercury Vapor Project and started a postdoc that John Baker had arranged. That was very nice of him to arrange, but with a postdoc, it's pretty well understood that you are trying to bolster your resume in preparation for moving on to the next position. And I'd been interested in working for Decagon at the time because I knew the folks, and also interested in working in instrumentation in general. But then I got a call, and I can't remember if it was Colin or Brian, but the call went something like, "Hey, we have a project to send a probe to Mars. You want to come work on it?" And so that was pretty much that. When you're weighing on one hand, postdoc or build a Mars probe, the build a Mars probe floats to the top real quick.
So what's your favorite thing about your job?
Well, I have a lot of favorite things about my job. And I do very much enjoy working with good friends, but I also enjoy the work that we do. Coming from an academic and field research background, the things that we do here, both in instrumentation design and instrumentation improvement, and the telemetry tools that we're working on, and the software pieces that we're constantly developing, those all make the field research job easier, and actually the lab instrumentation as well. The things that we do here are a big boon to, the folks that are in the position that I used to be in doing academic research. I mean, I believe that the work that we do here, bringing new tools and new instruments to the scientists, I mean, they open up new veins of discovery. And so that's pretty rewarding.
Any other fun stories you'd like to share and things you learned from them?
Come on, we want to hear the rattlesnake story.
Well, so one of the interesting projects was one that Colin may also talk about, that we worked together on some CO2 and water vapor fluxes in a couple of marshes. One was a salt marsh down by Corpus Christi in Texas, and another was a rice paddy near El Campo, Texas. And both places were just littered with snakes, right? And there's lots of poisonous snakes in Texas. And so, we were always cautious and wearing snake boots. But one time, Colin wasn't there. I was working with a lady named Faith Ann down in the salt marsh, and we were doing some research in the marsh at night. And we were finally finished up with the research, and we're trucking back, and there was a pretty well-worn trail. And so I didn't have my headlamp on, and I'm just trucking out of the salt marsh and walking, and a rattlesnake lit up in the middle of the trail right in front of me. And it scared the crap out of me. Turned on the headlight, and it was one of those South Texas big boys too, big around as your arm, easy. And he was curled up right in the middle of that trail. And I was I'd have stepped right on it, and I'd have been in a world of hurt. She'd have been carrying me to the truck. So I'm just super happy that rattlesnakes have that rattle. They're pretty nice creatures from that standpoint, that they give you a little bit of warning before they kill you. So that's one thing that I learned, is don't walk through rattlesnake country at night with no light.
So I got a quick story also along with that. The rice paddies are notorious for having water moccasins in them. And we were driving around in that spring setting up the site, and we saw, probably 5 or 6 water moccasins killed on the road just by cars driving along. And this was the dirt roads. This is, not heavily trafficked. And so we were pretty careful about avoiding snakes, but we were out sampling the root zone of this rice paddy with a big PVC tube, a 10 centimeter diameter tube. And you kind of jam it into the ground, pound it down, and then lift it up and put it in a bucket so we could go rinse the soil off and get the root mass. And when you did that, you kind of lifted the tube up and kind of banged it on a bucket to drop the sample in. And unbeknownst to us, when we lifted up one of our colleagues was out there lifting up this tube, and the water ran out from the back into the rice that was standing there. And it sounded for all the world like a water moccasin just shooting through. And my colleague almost jumped into my arms. When this happened, and we then realized it was just water out the back of the tube, but we were shaken for a good 5 minutes after that.
So why did you choose your specific field of research as opposed to another one?
I would love to tell you a story about, how this was a lifelong dream and how I had planned out, my entire career from my elementary school and knew I was going to be a soil scientist and environmental biophysicist, but that is absolutely not the case. I actually got my undergrad at Duke in environmental science. And when I finished up my undergrad, I didn't really have great job prospects. And so I ended up back in Bryan, Texas, which is where I'm from, and applied for a job at the university as a technician in an environmental physics lab with Jim Heilman. And I got the job because I could weld and because I went to Duke, and Jim was a Duke fan. But as part of that technician position, I had the opportunity to go to grad school. And this was about the time that I straightened up and decided I ought to do something with my life and started applying myself and actually paying attention in class. And I'm like, holy cow, this is super interesting. And so that is how I kind of happened into environmental physics. And I've enjoyed it ever since. It's been super fascinating. One of the things that I'm pretty bad about is bringing the environmental biophysics home with me, or maybe good about, actually. And so my wife calls me the pocket scientist, and this especially comes out when when we're out backpacking or something, I'm always preaching to the kids like, no, why would you try and dry your socks there? Those aren't the optimal drying conditions. You have to get some airflow across your socks, because then the boundary layer conductance is maximized and you're going to get way more drying. And oh no, you have to heat the socks and get them warm and get the airflow. Come on, kids. No, wait, there's no way you're going to put your tent out in the open like that. It's going to get condensation all over it. You got to get your tent under the trees, or you're going to end up with, being super cold at night. Like, come on, kids. And so that is the life of an environmental biophysicist, I suppose.
So does it ever get to a point where you obsess, where you're constantly seeing the world at an environmental biophysics level?
No, I don't think it gets that bad. I'm interested to hear Galen's answer to that question, because I'm imagining that he actually sees equations when he looks at natural phenomena. I stop a little bit short of that.
So Doug, what's the most promising research on the physical environment being done right now?
I am by no means an expert in this. In fact, I know almost nothing about it. But quantum physics are fascinating because they almost seem to defy the known laws of physics. And there are things there that are still at this point unexplainable, right, to science. And they're real, they're just unexplainable. And I think that advancing in those areas, that's going to be really interesting to watch for the rest of my life, I imagine.
All right, so moving on to Dr. Colin Campbell. Colin's been a research scientist at Meter for 20 years following his PhD at Texas A&M University in soil physics. He also co-teaches environmental biophysics at Washington State University, a class he took over from his father, Galen, more than 25 years ago. He's currently serving as research scientist and vice president of the Environment Division here at Meter. So Colin, you happen to work with Doug on his master's project at Texas A&M. Did you guys run into any bumps in the road while doing that project? And how did you overcome those difficulties that you did face?
So Doug and I researched down in the estuary near Corpus Christi, Texas. And I think it would be easier to say that what didn't we run into in terms of bumps in the road, and not what bumps in the road we ran into, because that project was fraught with challenges. First of all, we had a program in our data logger that was over 40 pages long. And when we started the project, neither Doug nor I knew anything about data logger programming. So one of the cool things about the project was that essentially Doug built this system from scratch, but based on a system that was built up at Kansas State University by a researcher named Jay Ham. And so we essentially copied that system, but had to harden it and prepare it to go into this estuary. And man, there were a lot of different things that were challenges for us. One of the most interesting ones was that putting these systems out in estuaries, you just don't imagine all the things that might attack your system. And one of the days we went down to the site, and Doug and I regularly drove the 4.5 hours down there and back, probably once a week or once every other week. And one time when we got there, the data logger enclosure was completely filled with ants. And I don't remember it being that long between, one day when we were there and there were no ants, and the day we got there and it was completely packed full of ants. Trying to get around that problem, trying to figure out the problem of power in the winter. We designed some pretty robust solar panels to make sure the thing stayed working through the winter. But with those low solar angles and limited sun time, we ran out of batteries essentially. And so one day we found ourselves carrying these lead acid batteries from interstate through the marsh. I think we went about 2 miles in boots as we were trying to keep our boots from flooding. And with a battery in each hand, we kind of trade off every little while. And not easy to set down batteries in the middle of a marsh, though. So those are some of the challenges we faced out there.
So what made you decide to come to work at Meter? And why do you like doing what you do? Well,
after grad school, I was looking around for postdocs and academic opportunities. And at that time, it was a pretty tight-knit family company. And my father had just retired from the university and come to work full-time at Meter Group. And as I sat down and thought about where I wanted to be, two things came into my mind. One was I'd love to work with my dad, who's an amazing scientist and a lot of fun to innovate with. And also, I really wanted to come back into this community of Pullman. It's a small community, but really educationally focused and forward thinking. And those are really the two things that got me back here. I mean, there's a lot of things that I love about Meter, and so glad I made that choice. But those were kind of the top of the list for coming back.
And what is the weirdest thing about your job? Or rather, is there anything that makes you laugh?
I think the things that make me laugh most are just the people I get to work with. We've got an amazing group of scientists and engineers and business people here. And these guys are hilarious, especially Doug. Doug always has a good joke loaded up for all of us, and usually a good practical joke loaded up for all of us. I give a lot of presentations around the company, and I gave a lunch meeting once, and Doug put together a bingo card for employees without me knowing it. And so I got up to give my presentation to 150 of the Meter employees. And little did I know that 40 in the audience had special secret bingo cards for words I love to use, like Wasatch Plateau and variable rate irrigation. And so they were filling in their cards. And everybody was smiling for the first time in my presentation. In all the presentations I've given, people were engaged. They were smiling. They were waiting, with bated breath on every word I said. And then I found out it was only because they were hopeful to win the bingo game.
So with all of those wonderful people, all the wonderful projects, what is your favorite thing about your job?
My favorite thing about my job here at Meter is just the opportunity to make a difference every day that I come to work. And I mean, now I have to do some administrative and some development, so those get combined together. But I love discovering new things and figuring out new ways to do things that are better, that improve. I think from my science background and things that I was taught, just every day having the opportunity to make a difference in maybe somebody's research, or if it's one of our employees in their life, to make them better, to help them grow in a new way, to innovate a new idea, or even to help people grasp a concept that they haven't grasped before, like the idea of soil water potential or soil water tension that Meter Group's talked a lot about lately, the idea that we can really understand the comfort level in plants and being able to connect that to our own comfort level, like a thermostat, and measuring temperature in our house. These things, discovering new ways to do things, or new ideas, ways to present to people, that's what I think is my favorite part of the job.
So how has being a scientist changed how you view the world?
Well, fundamental to soil physics, and particularly environmental biophysics, understanding with the way heat transfers, or the way mass transfers in a system, and understanding the engineering aspects of that. I mean, I can't look at the world the same way I did before I understood these things. When I go outside, I'm thinking about how heat is going to conduct from my body, and how much water I might lose by breathing water vapor out, and how much I have to drink again, and these stupid things. It's just a matter of our understanding these things kind of driving a lot of the choices that we make. And of course, whenever my children mention something, I don't need to wear a hat. We talk about the conductance of the head and how a hat changes, and then, come on, Dad, can't you get over the science of these things? So I see the world very differently than I once did.
Science as a whole has a great deal of influence or impact on changing the world for better. How have you seen, or how do you think science can help in, for instance, policy making or other things that really impact people's day-to-day lives?
We see a turbulent world right now, where questions related to what's real and what's fake continually come up. And I think the scientific process, where we ask questions and use the scientific method to answer them, are critical to be able to avoid and cross over many of these concerns about what is true and what's not true. And as we use the tools that we've been given to simply do our best to establish truth, we can move forward and be able to help in policy making, or any other thing that depends on the scientific method, to ask questions of what is right and what is wrong.
And with that, is there a best way, or what are good ways to translate science to the layperson, to communicate your findings, your results? Have you seen any good successes within that endeavor or any failures?
I don't know that I've particularly seen or even personally experienced one of those aha moments where I see that we've been able to cross that divide effectively. I see a real need for it, and it ends up being a real passion of what I in particular am trying to do in some of these things that Meter does, trying to help people who may not have experience at a scientific level understanding the benefits of some of the things that we can measure, for example. But some of the things that I've seen that work is simply try these things out on students, let's say, or on people who don't have experience in the sciences, and see how well some of these ideas connect, and whether they can achieve people who aren't experienced in this area the aha moments, saying, "Oh, I finally get it. I see that plants have a thermometer-like experience in the soil with water that's related to this weird thing we call water potential or soil water tension."
All right, if you could choose one question about the physical world that you could know the answer to, what would that be?
Here's my perspective, in all honesty. I think about solving problems one step at a time. And so there are these great problems out there that I'd love to know the answer to. What is the extent of our universe, and how many universes are there out there? But these questions can't be answered in my lifetime. And so the key questions that I think about are things that relate to our own Earth system. How can we establish and continue to thrive here on this Earth with all the interplay between human input and environmental needs? And being able to study and learn about that and be able to balance our world such that we can still have a society as we've grown up around and all of us experience, and yet safeguard and keep for the next generations this beautiful environment that we've been blessed with. I mean, that's the most important question, in my opinion, and it's a step-by-step answer.
And we saved some of the best stories for last. We'll now hear from Dr. Galen Campbell, who is one of the world's foremost authorities on physical measurements in the soil-plant-atmosphere continuum and the founder of Meter. His book, written with Dr. John Norman on environmental biophysics, provides a critical foundation for anyone interested in understanding the physics of the natural world. Dr. Campbell has written 3 books, over 100 refereed journal articles and book chapters, and has several patents. Hi, Galen. Tell us a little bit about the history of Meter, which was formerly Decagon Devices, and how it came to be.
Well, Decagon actually was started by my children. My wife Judy and I have 9 children, and so as the oldest got to be teenagers, why, you can imagine that we were wondering about jobs for them and where they could earn the money that they'd need for schooling and other things. And we'd had some experience in the past with starting small companies. Campbell Scientific, I was involved with that, and Westcor. And so Judy said, it would sure be nice if you could just come up with something that the kids could make and sell that they could use to earn the money that they need for schooling and other things. And so that was how Decagon was started. Campbell Scientific did the manufacturing. We started out with a thermocouple psychrometer, sample changer, and an nanovolt meter that would go with that. Campbell Scientific did the manufacturing. The kids put it together and did the marketing and customer service and other parts of that. And the company grew from there. All of our children worked in the company various times in their lives. Some of them still work there. Our son Scott is the president of the company. Colin is, as you've heard, the vice president, in charge of the environmental part. Our daughter Tamsin was a previously the president and now works in finance, and daughter Julia does marketing and technical writing.
You've been a research scientist and engineer at Meter for over 20 years, following nearly 30 years on faculty at Washington State University. Over the years, you've worked with many wonderful mentors. So can you tell us a little bit about some of your mentors and what they taught you?
There have been a lot of them. One that certainly stands out is the man who got me interested in soil physics. I did my undergraduate training in physics at Utah State University, but I grew up on a farm, and so I thought it would be interesting to learn a little bit about soils. So one quarter I signed up for a soils class, the beginning soils class. And it just happened that the soil physicist Sterling Taylor was assigned to teach the class that quarter. And so that was my first introduction to soils, formally at least. At the end of the quarter, Dr. Taylor came and asked if I'd like to work in his laboratory, and I eventually did that. So as an undergraduate student, had the opportunity to do research in soil physics. Dr. Taylor was an amazing person. He died at a young age. After knowing somebody like him, whose field was soil physics and environmental physics, it would be hard to choose anything else. He made it just the most exciting thing on earth. So that was unfortunate that we lost him. But even in the short career that he had, he did research in all of the things that I've followed for the rest of my life from that time on. All of the things related to the soil plant atmosphere continuum. And so he was the one that sparked my interest in soil physics.
So with all of those great experiences, those decades in academia, what made you decide to leave academia and come to work full-time at Decagon Devices, which is now Meter?
Yeah, that's an easy question to answer. Our daughter Tamsin was the president of Decagon at the time, and she came to me one day and said that my vice president of engineering is leaving, and I need somebody to take over that role. I'd like you to retire from the university and come go to work for me. And I said, oh, I think I'm too young to retire. And she said, well, why don't you find out and then let me know? And so went over to talk to the retirement officer. He had come to the university about the same time I had, and I knew him fairly well. And I said, well, how old do you need to be to retire? And he said, oh, you can retire anytime you want. He said, in fact, if you had come here 2 weeks from now, I wouldn't have been here. I would have been retired already. So I retired from the university and went to work for my daughter.
What do you enjoy? What do you love about working at Meter?
I often think as I sit and look at the screens on my computer, what a blessing it is to be able to work in a job like this. One screen will have a schematic on it. One screen will have some microprocessor code on it. Another screen will have some equations or something else that is just so varied to be able to do electronics, to do programming, to do science, and then probably more than anything to be solving problems that matter to people, that the things that we come up with increase crop yields, they reduce pollution, they make the world a better place to be. And I love working with customers, working with the people who are applying our stuff, and I love working with other scientists. I mean, I just can't imagine a more enjoyable job.
So, over the last 3 decades, you've invented and helped invent many successful instruments to measure the soil plant atmosphere continuum. And this is going to be kind of like a choosing your favorite child. But is there an invention that you are most proud of, and why?
Yeah, that is a hard question because there have been a lot of fun things. The ones that are most fun, I think, are the ones that involve some really fun analysis, some really nice science and equations, also some really fun electronics, and then combining those things to solve some problem. Uh, One area that I've spent a lot of time in is using heated needles for scientific measurements. Uh, so use them for measuring thermal properties of soil, heat capacity, and thermal conductivity, and then can use those to get water content. You can measure flow of sap in plants with the same kind of needles and the same kind of mathematics. The mathematics that apply goes beyond the hardest mathematics that I know how to do anything with. And then the electronics are also somewhat challenging. And then the kinds of problems that you can solve with that. Another one is the ultrasonic anemometers that started working with those back in 1977 to measure the vertical fluxes of things in the atmosphere. And Campbell Scientific built those for quite a long time. And then more recently, we've started building ultrasonic anemometers for measuring horizontal wind speed components. And again, it's demanding, the analysis is demanding, the circuitry is demanding, the those are fun problems to work on.
How has being a scientist changed the way you view the world? Do you get caught up in, as you're going out with your family or just by yourself, just looking around, observing the world, and seeing things through the eyes of an environmental biophysicist?
Well, sure. I was riding a ski lift one time and noticed that the wind was blowing across one of the pipes, one of the braces that held the seat up, and the wind wasn't steady. It was oscillating at a particular frequency, and it was neat to know why it was doing that. That was from eddies being shed off of that pipe. But on the other hand, my wife, who also, she does have some training in science, but she's just consistently a lot better scientist than I am. She doesn't know the equation for heat conduction, but when she wants to know if something is metal or styrofoam or something else, why, she goes and measures the thermal conductivity with her finger. I never would have thought to do that, even though I know all of the equations that relate to that. So there are people who are natural scientists, I think, and some who are maybe pretend scientists who just know the equations but not the applications.
Okay, final question. If you could choose one question about the physical world that you could know the answer to, what would that be?
I wish that I actually knew what the electrical conductivity of the pore water in soil is. That would seem trivial to, I suppose, most physicists, that they think, well, isn't that something you can know without any work at all? But we work pretty hard at it, and we still don't know that as well as we want to, or what's the water potential in the soil. So even pretty simple problems we don't have answers to. And there are surely a lot of days when I wish I knew the actual value, or what the value of the thermal conductivity was of a block of soil. We can get a number out, but whether it's the right number or not, that's the question.
All right, our time's up for today. And just a reminder, next week we'll publish part 2 of this interview, where we meet 3 more meteor scientists. If you have any questions, feel free to contact us at metergroup.com. You can also reach us via Twitter through our handle @meter_ENV. Our environmental research experts will be in touch with you to answer any questions, or we can put you in contact with today's guests. And you can view a full copy of the script in the podcast description. That's it for today. Stay safe, and we'll see you next time on We Measure the World.